So I got reconnected. There it is. Okay, this is your cover, right? You cut on the dotted line. We're going to start with commutative property, which is on the left side here. Let me get my pencil. So when you open up, right here, commutative property, open it up on your foldable. Look at the board. Commutative property states the order doesn't matter when adding or multiplying. I need you to stop playing your game. Put the calculator away, please. Then we're going to show that the order doesn't matter when adding or subtracting. So since the order doesn't matter, to show the commutative property with two terms, A and B, this could be any value. A plus B would be the same as B plus A. So basically what's happening for commutative property, I'm going to do this in parentheses, is that the values or your numbers, your values are going to move. So when we're adding two numbers together, for example, Jay, give me two numbers to add.
6, 7.
And
No.
and none of this 6, 7. Y'all need to stop with that.
What do you call it? 15 and 28.
Okay, 15 plus 28. Okay. If I add 15 plus 28 and I change the order around, like 15 plus 28, isn't that going to give me what, 43?
43.
Yeah. So would that change if I did 28 plus 15?
28 plus 15, no.
No. So put that away. We're not doing that in here. So the order does not change the value of your sum when doing commutative property. You can move the values around, switch the order, and it still be the same. Now this works also for multiplication. So if I have A times B, this would be the same thing as B times A. Same thing, if I have two numbers, let's say I have 3 times 5, it's the same thing as 5 times 3. They both come out with the same product. So for commutative property, we need to see the values moving. Okay. Now for our identity property, when we're adding, identity property is basically we want it to the value to stay the same, to remain. We don't want it to change. So if I add 0 to anything, the sum will not change the value. 0 is not going to change the sum. So A plus 0 is just going to equal what?
A.
Very good. Just A. It's not going to change the value of A, right?
Right, and for multiplication, 1 is practically the same as 0. Yeah.
So A times 1 equals A. So the identity properties for addition is 0 and 1 for multiplication. Now the 0 property, y'all should know that because anything multiplied by 0 is going to be what? 0. So multiplying any value by 0 will always equal 0.
You know about the law of equilibrium exchange.
Okay. So A times 0 is just going to be 0. I could have pi times 0 and it's still going to equal 0.
Is there any number like infinity times 0?
Infinity times 0. What are we talking about?
Okay. Anything times 0 still remains 0.
So in order to bypass.
Stop. All right. A reflexive property is values that always equal itself. Fill in the blank with itself. Okay. Think of it like a mirror image. If I'm doing reflexive property, we should see the same thing. Okay. So if I have A on the left side, the reflection of A is going to be A. So A would equal A. If I was talking about an integer like a -3, it's going to equal a -3. It will be the same value on both sides of the equal sign. Are we okay with reflexive?
Yeah, no conclusion.
Not until we finish this.
Aww. Let's get it.
All right, transitive property. If one value equals to two other values, then those two other values must be equal as well. Okay, there's a clue to see transitive. The first one is we should see the word and, because it's going to show a relationship between. The other thing is they should have a common part. So this statement says it's going to always be an if-then statement, but it says if A equals B and B equals C, then we're going to make the conclusion. So do we see how they have the B in common on both sides? Okay, so we talk about transitive. We use this property a lot in geometry, but the transitive property is like taking out the common part, take out the middleman. So if I take out the B that they have in common,
Then it's not common. It's not gonna be.
then what? Yeah, it is going to be equal. What are going to be equal?
Oh, the A and C.
Yeah, then A is going to equal C. Yes.
So how?
Okay, so if I know, so at this example, if I know 5 times 2 equals 10, right? That's true. I can get 10 another way too.
By 10 times 1.
I can do 10 is also equal to the square root of 100. That's another way of getting the value of 10. So they have 10 in common. I'm going to take that common part out. Then I can say 5 times 2 is the same as is equals to the square root of 100.
Oh, because they both will equal.
This, yes, they both equal the same value. Yes. All right, that's the left side. Do we have the left side down of our foldable? All right, let's go to the right side. Okay, on the right side, the first one we're going to talk about is associative property. This property, the key to this property, you need to see grouping. So you need to see parentheses. So the grouping of the value doesn't matter when adding or multiplying. Think to recognize the associative property, your parentheses will move. The grouping is going to move when we're showing associative property. So, did you fill this in already? So we have A plus B group, that's the first two terms. Then we're going to add C. So I'm going to, instead of group the first two, I'm going to move the parentheses and group the last two. So this is going to equal to the same as A plus, and now group parentheses B plus C. See how my parentheses moved from the first part, the left side of the equal sign, to the right side. So if I was thinking this like doing addition, if I do 2 plus 3 first and then add 4 to it, 2 plus 3, that's going to be 5, and then plus the 4 is 9 value, right? Would that change if I did 2, then group the 3 plus 4? No, because 3 plus 4 is 7, and then I add the 2, and that's still going to give me 9. So if I have A times B grouped and then times C, what is that going to equal to? How would I rewrite this moving the grouping? Who should the parentheses be around now if it's the first one is A and B? B, C. So this would be A times, then the parentheses, B times C. You keep everything in order. You just move the parentheses. Our inverse properties when we're canceling. Okay, so look at this. If I have A plus a negative A, what would that, or think of it like 1 plus a negative 1, what would this equal if they cancel?
0.
0.
0.
Okay, so a negative 4 plus 4 is still going to give you 0. So when we're canceling, we want it to when we're adding, we want it to become a sum of 0. So our negative a is the additive inverse of a positive a. This is when we're just doing the opposites to cancel. For adding, you have to make them opposite terms. Now, for multiplying, this is showing a times 1 over a. What happens is the a's would cancel and you would left with just 1.
I wish I was back to Kindle.
So 1 over a is a multiplicative inverse of just a. So for multiplying, you gotta flip the number. So here's an example, like if I have 2/3, I would have to multiply by what to get a value of 1? Flip that 2/3. What fraction would that become if I flip the 2/3?
It will be 2 over, no. What?
It'd be 3 over 2. Because when I multiply 2/3 by its inverse, it's going to equal 1. We want it to equal 1 to be the inverse property. Because this would be 6 over 6, and 6 over 6 is 1. All right, distributive property, the last, or 2 more, sorry. Distributive property is anytime we're multiplying a value to all terms that are going to be expressed inside the parentheses. So instead of writing the word parentheses, I'm just going to show the grouping symbol. So for distributive property, the parentheses eventually will disappear. You'll start off with some grouping, and then when you do use the distributive property, they're going to remove the grouping symbols. So I do want to talk about different ways of showing this. So like this a is outside my grouping. I know they have the dot here, but sometimes they don't show that. So hippity hoppity distributive property. I'm taking what's outside, bars, huh? And I'm multiplying it by what's inside. So look, a is getting multiplied by b. So that's saying a times b. Then I have my operation, which was the plus sign. I'm taking that same term outside of a, and now I'm multiplying it to c. I went for showing the grouping. Then when I do the multiplication, the grouping is gone. So let me show you how this is done algebraically. I need you to add this example. Most commonly, they would have a 2 or some type of term, parentheses, and let's say we have x plus y. See, I do need you to do this. I do need you to actively participate.
Oh, neck hurt, man.
So we're going to hippity hoppity distributive property. We're going to distribute the 2 to the x and to the y. So 2 times x, to show that multiplication, we just write 2x. Show the number and the letter side by side. That's showing multiplication. So it's going to be 2x plus 2y. Now, this is the example. I'm going to start this one because this is the one that I need you to recognize, because this is sometimes get misread in algebra. Let's say I have a negative and then parentheses 4x minus 5. What you have to recognize, guys, is if I don't see a number in front of the parentheses or in front of a variable, it's always an invisible one. So I know it starts off with just this negative sign right here. Look what you need to do, guys.
I thought we would just drop the negative.
No, we're not going to drop it. Xavier, if there's a negative sign and we don't see a number, it's always an invisible one. So you have to put the 1 there and distribute that negative 1 to each term.
It's just so much work, bro.
Stop it. Just stop it, please. Just, yes, fix your mindset. A negative 1 times 4x. What does that become? Negative 1 times 4x. What would I write? A negative 4x. Good. Now I'm doing this negative 1, but I have this minus 5. That's like a negative 5. A negative 1 and times a negative 5 becomes a positive 5. So now we make that plus 5.
My question is, when we put the units to go like,
I'm not doing that right now. You keep wanting to push the envelope, and I'm just going to ask you to stop. All right, symmetric property is an expression on different sides of an equation that can be swapped around. We can switch the order. So if I have A equals B, then I can say B equals A. I just switched it around. All right, so instead of writing each property out, guys, it says right here we're going to number the flaps 1 through 9 and identify the properties. So this right side, this is going to be the even side. So this is going to be my number 2. This would be my number 4. Sorry, dang it. Then this would be my 6. Number these so we don't have to write them out. And number 8. The right side that we just did, make that even. Just number them, please. The left side is going to be the odds. So this would be 1, 3, then 5. Sorry, come down. 7 and 9. I know I ran out of room. Because I'm just going to put the number that matches to the problem with that tab.
y'all lost y'all volleyball games too?
Okay, so here we go, guys. Number the flaps, we did that. Then identify the property by the number. Look at A. There's some clues. There's some clues to help you which one this is. Which property is showing here on problem A? Anybody see a clue? Yeah, the minute I see this times 0, that's a property of 0. So what number was that? That was 5. So we're going to put the 5 in that spot. Okay. On B, problem B, we have 10x equals 10x. Did it change?
No, so it's gonna be 10.
It's reflexive. It's a mirror image. We don't have a 10. We have a 7.
How is that a 7?
Like we have 9 properties, so we're just numbering them.
I thought we were actually solving this.
No, there's no solving. We're identifying the property. Okay, 10x times 1 equals 10x. It remained the same. Anything?
Just 7, right?
So that would be which property?
7.
No, it's not 7. 7 is reflexive. It's an identity. It's number 3.
Number 3.
Yeah. C was 3. Okay. Here's your clue on problem D. Okay.
You mean C?
We just did C. We're doing D. Okay, the clue on D, you see we have grouping? You see how it starts with grouping and then there's no more grouping? The parentheses disappeared. So which property would this show?
7.
It's just 6, distributive property.
Yeah, just 6. 7?
If 2x equals 7, then 7 equals 2x. Not the one. Which property do you think is shown here?
4. I mean, not 4. 9. Nope. No 9.
Nope, it is 8.
8, bro. What?
Because they just swapped
Can't believe
the
it.
order.
Yeah.
Does that make sense?
Yes.
All right. Now on F, again, here's the clue. Anytime I see grouping, I ask myself, did they move or did they disappear?
2.
You're right. It is 2. The parentheses just moved. That is associative property. All right, G, 3x plus a negative 3x equals 0.
4.
Good, 4, yes. Look at your grouping. This was a little tricky. Pay attention, focus, zoom in. Because we do have grouping.
9.
No, it's not 9. It is 1. Look, the numbers just switched. This is 1.
That means the last one is 9.
And the last one is 9. You're right. Okay. All right. Those of you, if you have your spiral, this is going in our next page after the pink in our spiral, or it's going into your math folder. I need your math folder out because I'm going to show you what needs to go in it next. Yes.